Hello guys, welcome to Creators Classroom YouTube channel. So in this video, I will going to teach about transformers. Okay, so most of videos on transformers, which is the core building blocks behind large language models, are designed for AI engineers, machine learning practitioners, and programmers. But what if you are a licensed student or from any other non-technical field? So that's why I created this video. So basically I am a biologist, and in this video I will explain transformers from biologist perspective using intuitive concepts and real world analysis rather than heavy programming. So my goal is to help researchers and students from life science and other non-tech disciplines understand the technology that is transforming science and society. So let's decode transformers together.
So this is the basic introduction of Perceptron. I am showing here. So the building block of artificial intelligence, okay, are simply the deep learning. If you take the deep learning, the building blocks are Perceptron. Okay, so this is the structure of Perceptron. There will be inputs. There will be an input layer, and each input layer, okay, this is a input layer, and this input layer is having multiple nodes. Okay, node 1, node 2, this is node 3, node 4, yeah, node E node. Okay, and here is where we input the raw data. Okay, and to each raw data the weights are multiplied, w1, w2, w3. Likewise, how many input nodes are there, those many weights will be there. Okay, we will multiply weights with the input data. Then we will get something called as dot product. Okay, dot product means it's a scalar value, a simple value. Okay, like 1.2, 1.3. Okay, a scalar, it's a scalar. So how we get this dot product? Simply we will multiply input with the weight, then we will do summation of all the products, inputs and weights product. Then at the end we will add a bias. Okay, so this one we call it as what we call as dot product. We denote, let's say we will denote it as a z. Okay, and then we will input this z, okay, or this dot product into a activation function. Okay, there are different activation function like step function, relu, okay, softmax, adam. Okay, there are different activation functions are there. The basic utility of activation function is the value of z, the value of z which is calculated from this dot product step, okay, or this node. There is a hidden layer. Okay, so it will be having lot of range. Sometimes it may have like 5 digits number, okay, or negative 5 digit number. Sometimes it might be having 0.00001, something like that. Okay, so the range will be very fast. So the function of activation function is to bring it into a certain range, let's say 0 to 1. If my task is classification, as I was saying in the sentiment analysis, if I give the paragraph to a model, it has to say the sentence is positive, or the sentence is giving a negative emotion, or the neutral emotion. Okay, so only three emotions are there. So this is ideally classification problem. Okay, so here we use something called as a relu. Okay, relu means if the z value is less than or equal to 0, then the output, the predictant will be 0. Okay, if the z value is more than 0, then the output will be 1. Okay, so likewise, so this is about the perceptron. They are very basic to understand the transformer. Okay, now this is the main ideology. Okay, the main idea behind artificial intelligence, that is, provided a data, input data, we need to predict the output. Okay, and we need to bend the line, the regression line, okay, according to the data points. So this is the basic difference between simple linear regression and the artificial intelligence. Okay, in simple linear regression we will draw a straight line. Okay, like the line might be like this. For example, the line can be a simple line like this, or like this. Okay, or it might be like this, anything. Okay, so a simple line, a simple straight line. But the problem is, using, if the data is very complex, okay, the simple line cannot be bent. Okay, it cannot classify, or it cannot fit to the complete data. Okay, so for that what we use is nonlinear model. Okay, so in the nonlinear model case, the main idea is we will bend this curve according to the data points. For example, we will take one example. Okay, so in the x-axis there is a drug dose, let's say paracetamol. Okay, I have to estimate the efficiency of paracetamol. Okay, how effective it will reduce the fever, how effective it is working on. Okay, on the y-axis is the efficiency, like 100% efficiency is ideal and 0% efficiency is not ideal. Let's say I will give the drug dose very minimum. Okay, 0.1, 0.1, 0.1, 0.2. Okay, this is the input dose of paracetamol. So then what is the output or the efficiency? It is near to zero. If I give the paracetamol dose, let's say around 0.5 mg. Okay, 0.5 mg, then what will be the efficiency? So here the efficiency is 100%. If I give the paracetamol dose 100, high dose, let's say 1 gram, then again the efficiency will be almost near to zero. Okay, so you can see here we are having three categories here. Okay, some group of observations are lying at the 0 0 coordinate, some are lying at this coordinates, and some are at these coordinates. By using simple linear regression, that is a single line, we can't actually touch all the point. Okay, a model is considered as very good if a regression line it will touch us all the data points. Okay, so that's why we need non-linear model. Non-linear model means they are simply curves. Okay, we have to introduce the non-linearity to the data. And how we will introduce non-linearity to the data? That is using perceptron and the activation function. You can see here in the last slide I was showing the structure of perceptron. So we are implementing here. For example, this is a single node. Okay, this is the single input node. So here we input the dose. Okay, dose of the drug. Okay, there is a dose of paracetamol drug here. Then we multiply each dose with a parameter. Okay, with a weight. So this is the weight multiplied by 1.43, and then we will add with a bias. Okay, then we will calculate the z product or the dot product, and then we will feed it into the activation function. Okay, here this case it is relu. If the value is less than 0, the y axis or the prediction will be 0. If the value is more than 0, the y axis, the y, that is the predictant, it will take the value of x axis only or the z. Okay, and finally we'll multiply with the weight, and we'll do the summation of like both the path. Okay, this is one path. From input it is connecting to the blue color hidden layer which is having activation function. Then there is another path, that is the orange path here. Okay, this represent another path or the neuron. So from or the perceptron, simply here you can consider this orange color as one perceptron and the blue color as another perceptron. Okay, so here also we do the same thing. Weights we will add, then bias we will weights will multiply, then bias we will add and feed into the activation function, and finally we'll get the output and we will sum it. Okay, we'll sum both blue color perceptron output and the orange color perceptron output, and finally we'll get the effectiveness. Okay, this is how we will bend the curve. So what is the advantage of this bending? Okay, like now you can say I have used all the data points. You can say in this diagram where my laser is moving. Okay, I have fed multiple data points to the model, and I have fit the model. Fitting the model means simply bending our line to all the data points. Okay, here different data points are there. By using the perceptron, okay, I have bent the line, okay, into a curve shape so that it will touch us all the data points. Okay, suppose let's say what is the advantage? You can say now I can consider this as a trained model. Okay, this is a trained model. Now what is the advantage of this model, trained model? Okay, let's say in future if somebody say my dose is let's say zero point 0.6. Okay, my dose of the drug is around 0.6. What will be the efficiency? Okay, so suppose let us consider this point. Okay, I will take the pen. Consider this as 0 0.6, 0.6. Okay, I'm very poor in drawing using this trackpad. Okay, so you consider this point as 0 0.6. Now I have to predict the efficiency of drug, so somewhere around here. Okay, so if the dose of the drug is here, simply you draw a straight line. Okay, perpendicular. you simply draw a perpendicular straight line from the x-axis, that is from where the dose of drug is there. So wherever this straight line overlaps with or intersects the curved line, okay, so this is the point where our straight line from point 6 dose is intersecting curvature or the non-linear line or non-linear curve. So the point here is 100. That means if the dose is zero point 0.6, if the dose of paracetamol is 0.6, its efficiency is 100%. Okay, so this is the ultimate purpose of any non-linear model, even including artificial deep learning, transformer. Okay, all those things. So now, moving to transformer. Okay, we will move to understand the transformer. But before that, one sentence is there here. Okay, so the sentence says proteins are synthesized in ribosomes and they act as building blocks. Okay, proteins are synthesized in the ribosomes. Read this sentence carefully. Okay, proteins are synthesized in the ribosomes and they act as building blocks. So the question here is, there is a term called as they. Okay, here you can see there is a word called they. So can you answer they refers to what here? Someone from participants?
Amino acids.
Yeah, means
Proteins.
here in this sentence it is proteins, no?
Proteins.
Proteins. Okay, so in this sentence they means proteins, right? Or if I remove proteins and put it as amino acid, the building blocks are amino acid. But imagine I do not know anything on the biology. Okay, I don't know anything science, any science I don't know. Okay, I'm just involved in some non-scientific things. I don't know biology, I don't know the science. So if you ask me this question to me, okay, what what the word they refers to, I may tend to answer ribosomes. Here you can simply observe this English sentence: proteins are synthesized in ribosomes and they are act as building blocks. That means they can refer to ribosomes also and they can refer to proteins also. Okay, so here I need something like, I need to understand the context also, in which context the sentence is framed. Okay, and which are the important terms I need to connect. For example, if I know biology, if I get training in the biology, if I read lot of biological texts or biological books, okay, textbooks, I can correlate. Okay, proteins means they. Okay, here the word they is referring to proteins. Okay, and this is exactly how the transformer architecture is built. Okay, the transformer architecture are built in such a way that each word in a sentence can connect with the different words. Okay, that we call it as attention. Each word, it will calculate the attention, how much attention I have to give it on the other words in the sentence, and it will capture importance attention. For example, here the word they is having maximum attention to the proteins. Okay, so this is how the transformer model work. And you remember I was telling the weights. Okay, weight 1, weight 2, weight 3 in the perceptron, these are nothing but parameters. Okay, weights then bias, they are nothing but the parameters. If the parameter numbers are more, then the model will be huge, the model will be bigger. I was in the beginning asking two questions. One is what is GPT, chat GPT, and another one is which is the highest cited paper till now. So globally, the highest cited paper till now is this one. Okay, some bacteriophage, some work related to bacteriophage. Bacteriophage means they are the viruses which will destroy the bacteria. They are called as bacteriophage. So it is having citation of around 3 lakh. But you observe the year of publication. It was published in the 1970. Okay, and attention is all you need is a research paper which is the main research involved in the development of transformer architecture. And this is developed by Google. Okay, this research work and paper is published by Google Brain, which is a core research team of the Google company. And the first author and corresponding author of this paper are Indians. So this Vaswani, Ashish Vaswani, he's a BIT, Birla Institute of Technology, Mesra. Mesra is one institute in Ranchi. Okay, BIT Ranchi. So he's a graduate of our Ranchi. Okay, so you can see here this screenshot was taken in last year. Okay, exactly 1 year before. So number of citation was 1,50,000. This paper is published in 2017. And now if you see, this is the screenshot took just like half an hour before. It is having 2 lakh, means just in a span of 1 year almost 80,000, okay, or more than 90,000 citations have came to this paper. Okay, that means people are using transformers like anything in whatever the field it is: biology, mathematics, science, robotics, space, climatology. You name a field, self-driving cars, there the transformer is using. And everyone who do research on the transformer, who use transformer, okay, they will cite this paper. Okay, and coming to the structure, okay, this is the architecture of transformer. So there will be embedding. I will show this animation how this work is, but from this slide you'll simply understand there will be embedding, okay, or the input block. This is called as embedding block or the input block. Then there will be a attention block. Okay, that too it called as self attention. Self attention means nobody will tell that in the proteins they are produced in the ribosome and they act as building blocks. Nobody will tell the word they refers to protein. The model has to learn by itself based on the training data. Okay, training data given. So this is the self attention. Then after self attention means it will learn by its own. So after that it will move on to the multi-layer perceptrons. Okay, multi-layer perceptrons basically it means a group of perceptrons. I have shown in the beginning a single perceptron. Okay, so likewise the multiple perceptrons, they constitute multi-layer perceptrons. They are also called as feed forward network. Okay, feed forward network. So a transformer will be having main 3 components. One is embedding block or the input block. Okay, you have to remember. Then there is a attention block. This is attention block. I will explain what are I will explain in detail. Okay, what are these. Then there is a multi-layer perceptron. So after completing this PPT, I will go back to some animations and I will explain how the transformer will work. Okay, what are the different components of transformers. So these are the different large language model. Okay, large language model published till 2000 or came into picture till 2024. I stopped following up these large language model after 2024. Okay, if you see the very first model, the GPT-3 model, okay, it is having the number of parameters 175 billion. What are parameters? In the very first slide I was showing perceptron structure, right? And there it was written w1, w2, w3, likewise wn, then a bias term was there. So in the same, in the single perceptron there were like 5 parameters. Likewise in the transformer architecture at different level, starting from the embedding, then at the attention layer, then the multi-layer perceptron, there will be different numerous number of weights will be present. Okay, numerous number of weights and biases will be present, and they are generally called as parameters. Okay, weights and bias, they are generally called as parameters. More the number of parameters, the more efficient your model is, the more capable is your model. Okay, and it can do any general task. For example, GPT-3 it is having 175 billion number of parameter, and Claude 3 which was published in 2024 it is having 2 trillion parameters. Okay, so just imagine how much big the model is. So this will marks the difference between the main difference between transformer and LLM. LLM stands for large language model. So transformer is a architecture. Okay, transformer is a architecture, and large language model, it's a model trained using architecture. Large language models, they are nothing but a general purpose models. They are trained using transformer architecture. Okay, so this you have to, these 2 terms you have to differentiate. One is transformer, it is basically a perceptron is a architecture. Then after that comes LSTM. Okay, I think yesterday you have studied LSTM, it's a architecture. Then recurrent neural network, it's one type of architecture. Then CNN, convolutional neural networks, that is a one type of architecture. So likewise transformer is another type of architecture. Okay, deep learning architecture. So one there is a popular repository called as Hugging Face. I have to mention before proceeding to the practicals. Okay, Hugging Face, from here where we will download the models. Okay, so how many of you heard about Hugging Face? Please respond. How many of you are aware of Hugging Face? How many of you are aware of GitHub? GitHub.
Sir, Avinash sir gave the introduction regarding the GitHub and even the GitHub in detail, but Hugging Face somewhat idea sir gave it.
Yes, madam. So GitHub basically like whosoever in the world they are programming, okay, they are doing programs, writing some codes. Finally, they have to upload in some repository, that is GitHub. Okay, people will upload all their codes into the GitHub. Why? Because in a single project, multiple coders, multiple researchers will be working. So everyone then need to access all the codes and they need to modify the codes. Okay, so that's why they will keep all the codes in a common place, that is called as GitHub. Okay, so GitHub is basically for any kind of codes, but that is not efficient. GitHub is not efficient to store the large language model. For example, in the last slide I was showing Claude Opus. It is having 2 trillion parameters. Okay, and recently I was using Quen. I was downloading Quen 3 into my workstation. Okay, Quen 3, it's a model LLM developed by Chinese group, and that was having 50 billion parameters. Okay, Quen 3 model, it was having 50 billion 50 billion parameters. You know what was the size of that model? It was around 13 GB. 13 GB, the size of simply the size of model is 13 GB, and to run that model at least we need 40 GB graphical processing unit. Okay, the 40 GB graphical processing unit. Okay, to perform deep learning, to train a deep learning or to use a deep learning models like transformer or LLM models, you need to have a graphical processing unit. So in the computer there will be two components, one is CPU, okay, and another one is GPU, graphical processing unit. If you want a speed, if you want, like suppose you want to go from here to New Delhi, okay, if you want to go from New Delhi to London, okay, you need the speed, right? You need to move fast. So whatever the operations or whatever the code executions which require speed, computer will intelligently divert it to the CPU. But suppose let's say you want to import lot of goods from America to India, or you want to export some agricultural products from India to some different country. Is using aeroplanes is efficient? The question is no. Okay, so there we have to rely on the huge ships, container ships. Okay, so the container ships are, they are very slow. The movement of container ships is very slow, but they can accommodate lot of storage, lot of containers, they can carry lot of cargos. Okay, so likewise GPU, they are built for handling this lot of tasks like mathematical tasks. So basically this Perceptron or the any deep learning framework, basically they are nothing but in the background you will be doing mathematical operations. I will show in animation in just 2-3 minutes. You will see the mathematical operations like multiplication, then dot products, addition, okay, these kind of thing. So to perform these things you need GPU. Okay, to perform these multiple mathematical operations simultaneously you need GPU. Imagine to run 2 trillion, I'm telling you, to run the 2 trillion model you need at least 400 GB graphics card. Okay, 400 GB graphics card, and the cost of 80 GB graphics card along with its compatible computer in India at present is 1.2 crores. Okay, that means to procure 400 GB graphical processing unit capacity, we need to invest at least 5 to 6 crore. Okay, so that's why Claude, beat a ChatGPT, beat a Claude, beat a DeepSeek, they will charge some money. Why they will charge some money? Because to host these models they have to host it in a supercomputer. Okay, supercomputer, and the computer they are itself are very costly. The companies have to recover the money, no, they have to pay for those infrastructure. And also these GPU, they are power hungry machines, they will consume lot of electricity. They need to pay for electricity bill also, they need to pay for cooling also. So that's why behind certain limit ChatGPT will ask for subscribing them. Claude will ask for Claude is a model of Anthropic. They will ask for subscription. Okay, that's why they charge the money. So Hugging Face is a repository where all the models will be deposited. Okay, for example, you can see here in this screenshot, you can see DeepSeek model. Okay, DeepSeek model is stored here, okay, in the Hugging Face. So it is having three options. One is models, one is data sets, and another one is spaces. Models is the place where, are the option where you will store or you can find all the large language models, and data sets is place where it will store all the data sets. Okay, the data sets which are being used for training LLM, they are stored in the data sets. And spaces means they will give computational power, means they will give a virtual computer so that you can run some big models. Okay, so that you can run big models using Hugging Face. You can run ChatGPT with lesser cost. Okay, with lesser cost. So space is actually they will be giving computer. So today what we will do in our practical is we will download some models from the Hugging Face directly into the Python programming language, and also we will download some data sets from the Hugging Face. Okay, and we will analyze for model adaptation, means we will perform model adaptation using Google Collaboratory. Okay, do you know Google Collaboratory? Anyone? What is Google Collaboratory? Okay, no issues. I will explain later. So this is the Google Collaboratory. Okay, I will show. I will introduce you to the Google Collaboratory and how to execute code here, how to connect to Python, how to perform take R programming options. Everything I will show here. So before that, before going to the practical, this is the last section I wanted to show it to you. That is transformers. Okay, the architecture, how the transformer architecture work. Okay, so this is a website built for understanding how the transformer architecture work. Okay, so as I was saying, as I was explaining in the PPT, so the transformer is having three main blocks. Okay, our main components. One is the embedding component. Okay, this is the embedding component. Then here it is the attention, self attention, because they learn the attention in a nobody will teach. Okay, based on the data they will learn, that's why they are self attention. Then there will be a multi layer perceptron. Okay, so now we will go deep into this understanding transformer. For example, imagine there is a sentence. Okay, there is a sentence, means the prompt. You imagine you are going to give this prompt to a chat GPT. Okay, so basically this model architecture is there. No, it is of GPT-2. Okay, chat GPT-2, it was published in 2020. Okay, so this animations, mainly the background model is the GPT-2 only. So data visualization empowers us to. Okay, this is the prompt. So the task for this model is transformer or this LLM is to predict the next word, right? If you enter anything into the chat GPT, it will predict the next word. For example, if I enter this data visualization empowers to. Okay, for example, I will generate. Okay, I will take freshly. Sorry, I have to take this fresh because I have already used this. Okay, we will take some different example. The example is artificial intelligence is transforming the. Okay, the next word it predicted is, you can see here. What is the next word it is predicted? It's way. Okay, now this is a output where it is showing 100% probability. Artificial intelligence is transforming the, this was my prompt, and it predicted the next word, which is way. Okay, right, way. One second. Okay, it's predicted as way. Now this output, remember this carefully, this is very important for understanding one more term. Okay, that is auto-regression. Okay, to understand what is auto-regression, you need to pay attention here. So the word way, which is a output of running one time, this will act again as input. For example, artificial intelligence is transforming the way. Okay, the way, word way, which was a output in the previous run, it will act as input for the next run. Okay, so if I run this, you can see here in the embedding. Okay, now the way is appearing, which was once a output, now it is appearing as input. Now all the way along it predicted the word V. Okay, now what will happen? This V word will act as input. Okay, this is the output now. It will act as input now again. Okay, in the for the next round. So artificial intelligence is transforming the way we next. Okay, I'll click on generate. Means I will run one more time. So yeah, it predicted the word think. Okay, now this will act as output. We will run it quickly. This is the last example. We'll take it. Okay, about the world. Maybe it is going to predict about the world. Okay, about the world. So my point here is each output produced will act as the input again in the next round. This is called as auto regression. Okay, so that's why you enter some prompt into the chat gpt, all the content will not appear at once. Okay, for example, I will open chat gpt. Okay, AI is transforming. Okay, you simply see in the output. Okay, word by a word it is appearing. Okay, see, one word is appearing at one time. Okay, after completion of each word the next word is appearing. You can observe it. Okay, this is called as auto regression. Okay, auto regression, and it will keep on the large language model will keep on producing the text till it reaches some special tokens called as EOS, end of sequence tokens will be there. When those end of sequence tokens will appear, then model will stop running. Okay, that's how we will get huge amount of response here. See, my prompt was this much only. My prompt is AI is transforming the. It has printed so much of thing. Okay, that means it has run multiple times. So now we will understand this architecture. So you can see here each word, each input word, okay, each input word is divided into tokens. Sometimes if the word is very small, that is considered as a single token. For example, the word art, okay, means you can see here is the word is. Okay, the word is a small word, no. Okay, it is having only two character I and s. So it is considered as a single token. But the word artificial, okay, the word artificial is something bigger. Okay, the word artificial is little bit bigger word. So that's why this is broken into two tokens. Okay, so each of these are called as tokens. Okay, ERT is called as a token, facial is a token, intelligence is a token, is a token, transforming is a token. Likewise, these are called as tokens. So this is your input. Okay, but the letters, the characters like A, B, C, D, E, F, G, H, okay, these cannot be processed mathematically. To perform something, some operation, if you want to perform mathematically, you need the numbers. You need the numbers, right? So that's why each token will be having a ID number. You can see the ID number of ERT is 8001. The ID number of official token is 9542. And these token embeddings, okay, token embedding ID numbers, they are unique for a LLM. Okay, so in the chat GPT-2, in the GPT-2 model, the vocabulary, we call it as a vocabulary size. Okay, the entire English words, the entire English vocabulary is made into 52,000 tokens. Okay, how many tokens are present in GPT-2? 52,000 tokens are there. Okay, so like the model like Claude, okay, they are having 1 lakh tokens. Okay, the entire words in present in the English language, they are tokenized into 1 lakh tokens, and they have given each token a unique ID number. So this is unique. So wherever the word is there, okay, the wherever the word is there in the input, the ID number it will give it as 318. Okay, these are fixed. ID number are fixed. Then to these token embeddings, what we do is we will add the positional encoding. Okay, don't confuse with the embedding. Okay, embedding means simply you can understand they are input. Okay, embedding means what? They are input. Just a minute, someone is making a call. I'll okay. Sorry for the interference. There will be token embedding, and we have to add on positional encoding also. Positional encoding means the order in which each token appear in our prompt. Okay, the order in which each word appear in the prompt. For example, art. So the positional encoding, like if you see Python programming, every position it will start from 0. Okay, the position will start from 0 comma 1 comma 2 comma 3, like this. Okay, it will never start with 1. Okay, it will start with 0. So that's why you can see here 0 1 2 3 4 up to 9. Okay, up to 9 tokens are there. So that's why 10 tokens are there. So that's why 9 inclusive of 0, that is total 10 ID positional encodings are added here. Okay, this is about encoding. Okay, this is about embedding. So this is the first part. Okay, so after this comes is dropout, then residual connection, and layer normalization. I will tell what are these at the end. Okay, I will tell what are these dropouts, layer normalization, and residual connection at the end. But now we will move on to QKV matrix. Okay, this is the means these QKV, they are very important integral aspects of transformer. Okay, because they make attention. Okay, they will create attention of each word with the another word. And how they create, this is very interesting. Please see. For example, there are embeddings. Okay, there are embedding. So here, what is the embeddings means basically it is represented as matrix. Okay, so here you can see, please pay attention here, the dimension of this, okay, the shape of this matrix is 10 comma 768. Okay, 10 comma 768. 10 is number of row. Okay, you can see each token is corresponding to one row. Okay, that's why it is 10. And then comes 768. And what are these? Means 768 means these are features, these are the columns. Okay, like for any basic mathematics, this machine learning classification, you can visualize a data. Okay, you typically the data will be having some rows. In the rows there will be observation and there will be columns. Okay, and columns nothing but they are features. Now we call them as feature. Okay, so these features are fixed for a model. Okay, I was telling the vocabulary size for a particular large language model is fixed. For example, GPT-2 it is 700 and 50,000 something. So it is fixed for GPT-2. So likewise, the number of features, okay, the number of features which are present in the column, they are fixed for each LLM. Okay, for GPT-2, the number of features are 768. Okay, and who will going to estimate these features? Can anyone do a wild guess? How these vectors means basically it's a matrix. Now I will take, for example, I will open the Excel. Okay, so basically here is odd, means the embedding means my token official, then is, so up to how many number of tokens were there? 10 number of tokens were there. And in the columns, okay, these are all our features. Okay, so this is feature 1, then this is feature 2, feature 3. So likewise, how many features are there? 762. Okay, feature number 762 are there, and these are what? Tokens. Okay, this is token, total token 10 are there. So this is ideally a matrix, right? So here there will be a value. Okay, here there is a value x1, here there is a value x2, here there is a value x3. Okay, likewise all the entries, all the elements of this matrix will be having some values. Okay, all the elements of this matrix will be having some values. And how these elements are calculated, who will going to calculate these elements for us? Okay, so the process of finding out values for each elements in the matrix is called as pre-training. We say now we are training a model. So what is the meaning of training? Okay, what is the meaning of training? The meaning of training is it's a art. It's a art of finding out values for each of the elements. Okay, there are two things here. I said parameters. In the beginning I was showing the slides. I was saying parameters means they are having weights and bias. Now these values are also considered as parameters. Okay, now till now I have told you three types of parameters. One is weights, another one is bias, and another one is elements of these matrix. Okay, all these are considered as parameters, and these parameters are learned by the model itself during the process of training, pre-training. Okay, so this is about how this matrix came. Okay, if this is clear to you, we can move on to multiplication with the QKV. Okay, there are three matrices are there. Okay, three matrices are there. Q stands for query matrix, query, QUERE, query. K stands for what? Key, KEY. K stands for key, and V stands for value. Okay, query, key, value. So let us understand what are, before understanding these query QKV matrix, we will understand what are these actually. Okay, what is the logic behind query, key, and value. Suppose I'm going to a YouTube now. Okay, so I'm going to YouTube. Let's say I want to find out something on, I want to search on Ramayana. Okay, recently Ramayana is a movie. No, the budget is projected to be around 4,000 crores, which is going to be released during this Diwali, acted by Ranbir Kapoor in the Rama lead, and Yash in the Ravan role. Okay, I want to search Ramayana. Okay, so this Ramayana is query. Okay, remember this. I am simple analogy giving. I am explaining the simple analogy to you. So Ramayana is what? It's a query. I am entering it now. You can see. Okay, you can see some video, some YouTube shorts. Okay, all of these are appearing here. Okay, these are all okay, and also there is a link. Okay, this is what, this Rama pipe Namit Malhotra Ramayana pipe Nitish, then Ramayana Katha Lanka Khand, then Ramanand Sagar. Okay, these are called as key. My query was Ramayana. Okay, my query was Ramayana, and I have got key. Okay, these are all keys. This is one key, this is the key number 2, and this is the key number 3, this is the key number 4, so on. Okay, these are the key. Now I want to know the value, and how we will know the value? Value can be known only by opening this video. If you open this video and play, okay, if I open this video and play the video, then only I can know the value. Value means what? It's like content, what actually the content is. Yeah, so I opened this. So here some teaser related to this movie is playing. So this is the actual value to a query, which was the query I asked Raman. Suppose here it is also showing one more key. Here it is also showing one more key, which is Ramayana episode 43. So if I open this, some video will play, but what I was looking for the information regarding Ranbir Kapoor's movie. Okay, but here some different similar search. Okay, some different similar search has been made by the YouTube, and it is displaying. Okay, so this is about query, key, and value. Okay, QKV. Okay, so now coming back to here, we'll understand the matrix. Now, what is this dimension of each matrix? What is the dimension of query matrix? What is the dimension of key matrix? And what is the dimension of value matrix? We'll understand. So the dimension of query matrix is 768 multiplied by 768. Simple. So how many number of features are there in our data? Okay, means for example in the ChatGPT 2, the number of features are 768. Okay, so the dimension of query matrix is simply 768 comma 768. It's a square matrix. So likewise, the dimension of K matrix is again 768 by 768. Then weight matrix is again 768 by 768. So, and these matrices are concatenated. Okay, what is the meaning of concatenation? Concatenation means it's not like element to element addition, element to element subtraction. It is not like that. It is simply the concatenation. So that means say this is one matrix, then this is the another matrix. Simply I'll keep adjacent to it. Okay. So likewise, if I am having one more matrix, I will keep adjacent to it. Okay. This is called as concatenation. Okay. They have concatenated it. Okay. Now we have to perform this QKV matrix with the embedding matrix. Okay, embedding matrix dimension is 10 comma 768. Likewise, QKV matrix dimension is 768 into 2304. And what is the primary rule? Okay, what is the rule for multiplying two matrices? The column, okay, the column of pre-multiplication matrix should be equal to the row number of post-multiplication matrix. Okay, so here the column is 768, which are our features. Okay, and here in this matrix it is 768. And can anyone tell how this 2304 came here? I was telling about matrix concatenation. Can anyone tell how this 2304 came here? See, these are very important things. Artificial intelligence is nothing but simply statistics. Okay, it's very basic: multiplication, calculation, subtraction, addition, only these things. You are not performing anything, but you are doing it in a logic. Okay, you are performing all this mathematical operation in a logic. Okay, so that is how the simple statistics is built into AI today. Okay, AI and statistics both are same. If you want to excel in AI, okay, if you want to do research in AI, okay, you want to be very thorough in statistics. Forget about mathematics, we don't need it. We have to be very thorough with statistics. How this 2304, please listen carefully.
Sir,
How
after
this,
concatenating,
yes, very good. How this 2304 came is, see, the number of column of this Q matrix is 768, and the number of these columns of K matrix is 768. Likewise, the V matrix, the number of columns are 768. So 768 plus 768 plus 768. So it is giving to 2304. So now we are having columns of pre-multiplication matched with rows of post-multiplication matrix. So we can simply multiply it. So can anyone tell what is the dimension of the product matrix?
10 comma 2304.
Yes, very good. See, simply these common numbers will get cancelled. So the number of rows in the multiplied means ultimate the product is 10. 10 number of rows will be there, and 2304 number of columns will be there. Okay. So now we have multiplied embeddings. Okay, we have multiplied embeddings with the QKV matrix. Now we are going to add the bias. Okay. So if you see the perceptron, okay, the perceptron is like the ideal concept. You have to, at any given moment, you need to understand perceptron should come onto your screen, okay, onto your eyes. Even if I wake you up from the sleep and ask what is perceptron, you should visualize this image. Okay, see here we are adding this bias term, no? So that's why these transformer, they are basically nothing but deep learning models only, which are inspired from perceptrons. So we are adding here the bias. So means these are addition, means the number of columns should be same as here. Okay, so here the number of columns are 2304. Okay, and we are adding the bias. So ultimately, after multiplying and addition with the bias, we will get a matrix which is having dimension of 10 comma 2304. So this is how QKV matrix came. Okay, so now moving on to the next topic. Okay, now we are having QKV. So you see the animation. See the animation first. Now I'll explain. So each token will be getting attention. How the attention came? How the attention came? Attention came with the help of QKV matrix. Okay, after multiplication of QKV matrix to the embedding, the model learned the attention. Okay, and all the see what was the dimension of QKVV matrix, QKV, and we have added the bias. The dimension of that matrix was 10 number of rows and 2304 number of columns. Okay, that's a vast, like big matrix is there, but here it is represented as one dot. That means we are doing the dot product. Okay, dot product, we are doing the dot product means like be it a vector or a matrix, we will somehow bring into a single scalar value. So this is called as dot product. So here the value of this dot product is 5.8. Likewise, for each of the word combination, for each of the token combination, QKV matrix will be built. Imagine the number of computation required. Okay, how many number of mathematical operations we have to do? Means we have to do matrix multiplication. Okay, matrix multiplication to get the each attention, we have to multiply a huge matrix multiplication, right? So that's why I told we need GPU, graphical processing unit, for this purpose. And in India currently we are in lack of GPUs, graphical processing units. So that's why we are lagging behind in AI research. And China, America, they are having huge number of GPUs. Even this Trump, okay, Donald Trump, he has imported sanctions on importing GPU, okay, to the China. Why? This Trump and America, they feared that if we give more number of graphical processing unit to China, they will progress like anything. Okay, they will progress and they will become top in the world. Okay, that's why they have imported this ban, and only one company in the entire world is producing GPU. Okay, that is Nvidia, and recently AMD company, AMD. Okay, they are also started building, but GPU cards will be having like many number of transistors, and those transistors are built by single company. GPU cards are built by two companies, Nvidia and AMD. Okay, but the chip, silicon chip, where the multiple transistors are typed, okay, they are produced by only one company in the world, that is, I think, present in Denmark. You please go to YouTube later and check a video from Think School. Okay, I will show uh, GPU by Think School. Think School is a very good YouTube channel. So he has made a video on GPU cards. So he has made a video on this one graphics card. You can watch it to understand what are GPU cards. But coming back to our business, so I was telling how these attentions means very big matrix are came into a single scalar value, that is a dot. Okay, that is by dot product. Okay, and for each of these token combination, okay, how many token combinations are here? I will take another simple example. Okay, so here the example is data visualization m powers user 2. Okay, this is an example here, simple example we have taken. And how many combinations of dot products we have to make? So total number of tokens are how many? 6 tokens are there, no? 6 tokens are there, and for each of them we need 6. Okay, so 6 multiplied by 6. Okay, so 36. So you can see here 36 attention weights are there. Okay, 36 attention weights are there. So now some another crucial topics comes here. Once we get the attention, what we have to do is we have to do scaling and masking. What is scaling? Scaling is, can simply think it as taking the average. Okay, or in another simple sense you can think it as doing normalization. Okay, suppose let's say I have collected the number of marks obtained by 20 students in a class, and I have to normalize it. So how do I do normalization? So I will calculate mean value from all the 20 observations of marks. Then each value I will deviate with the mean. I will square the deviation. Then I will divide it by the standard deviation, or the number of observation, which is 20. So likewise here in case of scaling, what they have done is, to the query and key matrix, okay, you can see here, you can see the formula q multiplied by k transpose divided by dimensions. Okay, d stands for dimensions. Okay, so that's a dot product of dimensions. How many dimensions were there? Dimensions nothing but number of features. Okay, here the number of features was fixed in the GPT-2 model, which is 768. So d is a dot product of those 768. So scaling is done to normalize. Okay, scaling is done to do the data normalization. Okay, so now after doing scaling, what we'll do is we will add mask layer. What is masking? If you closely observe this matrix, the upper triangular matrix, the values are upper triangular matrix are set to 0. Okay, why? The values of upper triangular matrix are set to 0. That's why they are appearing grayish color, and only the lower triangular matrix, they are having some value. Okay, the reason being masking here is, we are avoiding the model to learn from the same tokens twice. अगर हम masking नहीं करता है, if we do not do masking, what will happen is, the same number of tokens, they are considered twice in the training data, and that will lead to massive computation. Means the computation power, let's say now I need 100 GB graphics card. So if I do not do masking, I may need 200 GB graphics card. This is problem number 1. And the problem number 2 is, the model will learn from the future token. Okay, means after doing this attention, the model will already be guessing the future word. Okay, so for example, here the future word, or the future means, I'm saying future, future. Okay, the output here, it is the visualize. The visualize word is actually present in the id numbers. No, I will tell output. Already output, the vocabulary of ChatGPT will be having that word, and after doing this attention, the model will get a fair idea on what will be the future token. And if you do not do masking, the future word, okay, the output which is not yet the output which is not yet predicted will also consider in the input, and that will cause the bias. So massive amount of bias will be caused. So that's why masking is performed. So simply you remember two things. Okay, masking is done for two reasons. One is to reduce the computational space, and to avoid model learning from the future tokens. Okay, to avoid model being learned from the future tokens. So these are the two reasons for masking. Okay, so now we have multiplied the matrix query and k. We have taken the dot product, and after that we have done the scaling. Okay, scaling means we have divided with the dot product of vectors. Okay, then we have done the masking, that is, we have set upper triangular matrix value to the 0. Okay, so next comes the softmax. Softmax is what? It's a type of activation function. Okay, so in the very beginning I was explaining about ReLU. Okay, so here the activation function being used in these hidden layers are ReLU, RLEU, rectified linear unit. Okay, and what they do is, if the values are 0, if the values of x-axis are 0, it will predict y-axis as 0, and if the value of x-axis is negative, then it will predict the value of y-axis as 0, and if the value of x-axis is more than 0, let's say it is 0.5, then the y-axis is predicted as 0.5. Okay, so this is the function of this activation function, and activation functions are the one which introduces non-linearity to the model fitting. What is non-linearity? If I say the non-linearity word, you should imagine non-linearity means curving the regression line. Okay, to introduce curves in the regression. Okay, so this is a non-linearity. Okay, see, These are not a straight line. These are bent line. Okay, these are non-linear lines. So moving to the next. Okay, after doing softmax, some values will come. That is query and k matrix value will come, and to that we will add values again. Okay, the values again. Now we got key matrix, query matrix, value matrix, and we have performed dot product, scaling, masking, and softmax, which is activation function. These many things we have done. And now you can see here, if you see here closely, here it is written as head 1 of 12. This is a single head, okay, single self attention head. So likewise in the GPT-2 model there are 12 heads. You can see if I keep on clicking this rightward arrow mark, the number of heads are changing. Now it is at head 7, head 8, head 9, head 10. Okay, it is using 12 model. That means the tokens or the input words, they are being learnt in all the combination, in all the possible way. Okay, I was giving an example of proteins are built in the ribosomes and they act as building blocks. Okay, building blocks of life. Okay, here there are so many like concepts are there are so many words are linked. Proteins are linked to ribosome. Okay, ribose, and then proteins are again linked to the building blocks. Okay, proteins are linked to ribosomes. Why? Because proteins are produced in the ribosomes. And again in the another context, proteins are building blocks. Okay, that is the another link. Okay, so I can simply think it as in the first head. Okay, in the first attention head, in the first self attention head, the protein word is getting learned. Okay, is made to learn the linkage with the ribosome. Means the relation between protein and ribosome is learned in the first attention head. And in the second attention head, the protein, the linkage of the protein and its relation with the building block, okay, the term building block, it will be learned in the second head. Okay, so usually when we give a large data, okay, usually we copy multiple sentence and feed into the ChatGPT, no, into the LLM. So there will be lot many context will be there, a huge story will be there. The model has to understand all the story. So that's why multiple heads are being developed. Okay, so more the number of multiple heads means more the number of heads, more the number of parameters. Okay, and the model size will be very big. The model size will be very big. Okay, so that's why nowadays whatever the models being developed, they are having multiple heads, 30 heads, 50 heads. Okay, now each head, each attention head will give some value, and again they are concatenated. You can see here, you can see the animation here. Okay, means the vector value coming from one attention head, the vector value, that's a single vector now. Okay, it has become, I will show. Wait a minute, please. You can see here. Okay, the ultimate vector we get now after this addition of value one more time, the ultimate vector we get will be a single vector. Okay, of 768 dimensions. Means 768 features are there, no Amara. Initially we have considered 768 features. Okay, so those 768, but this time some values will appear, and how this model will fit into the value, that is by training, pre-training. Okay, so concatenation means these 768. Okay, now see how many number of tokens are there, 6 number of words are there. Okay, so one vector. Okay, this is one, you can imagine this says one column vector for first attention head, means first attention layer, and this is one more vector. Okay, one more vector concatenated to the first vector, which is produced from the second attention head. Okay, likewise here 12 attention heads are there, so the dimension of the matrix will be 12 rows. Okay, 12 rows and the 768 columns. and if you transpose it, it will be different. Okay, just it will be the reverse. Now just a minute. Now one more concept is there. So before feeding into the multi-layer perceptron, we can see here for a single word there will be one multi-layer. Means for single layer there is a single perceptron. Okay, this is one single perceptron. For visualization, one perceptron is there. For EM, one group of perceptron. Okay, so likewise different group of perceptrons are present here. But before feeding them into the dropout, what we do is we will remove some vectors. Okay, we will intentionally set the values of some vectors as na means not available. Okay, why? Because by setting the values as na, the model will become even stronger. Means the model will learn, even in the absence of some vectors, it will learn to predict the next one. That means our ultimate purpose of building the LLM is to make a general model. General model means, for example, to the ChatGPT, if I ask something about cricket, it will reply. If I ask something about the science, it will reply. Okay, because the training data is having all the domains data, and also to make the model very robust, to make the model generalized, they will add dropout. Dropout means intentionally they will remove some these vectors. Okay, these layers they will remove. And don't worry, I know this is like a concepts heavy topic, but I will share this link with you. So all the explanation, okay, if you spend 10 minutes of time, you can find out all the explanation here. Okay, so no need to worry. And ultimately, to the multi-layer perceptron, one more activation function is fit, that is GELU, GELU. That is like something similar to ReLU only, but this is a G stands for I think geometric. I don't know what is GELU. Then after that, what we do is we add a residual connection. This is very interesting. And see, the sentence I was saying, no, proteins, they are produced in the ribosomes and they act as building blocks, right? And here I told the large language model will learn the word they refers to proteins. Okay, this is because of two reasons. The one very main reason which contributes to 90% of this context matching is attention, and another 10% is being contributed by the residual connection. Okay, residual connection means, okay, in while moving forward, means while moving forward for prediction of the final output, these residual connections they'll consider the input again. हमारा input क्या आता है? Our input was data visualization m power s2, and after that we have built a QKV matrix. Okay, and we have concatenated all the values, all the vectors from multiple heads. Okay, then after that we have done dropout. Okay, dropout means we have deliberately removed some vectors from the some neurons. Okay, some perceptrons, and after that we have introduced activation function. And finally, just before calculation of the probability, again we will add the input. Means now the model is very sure that whatever it has predicted, okay, whatever it has predicted that this word is having relation with the another word, it's like a validation. Yes, whatever I am doing is correct. Okay, so that is the purpose of having residual connection here. And finally, now we have reached the final aspect of transformer architecture. Okay, that is called Logits. Now what are Logits? They are simply the likelihoods. Okay, likelihoods which are expressed in negative logarithm. Likelihoods which are expressed in the negative logarithm. And I have told you in the beginning that ChatGPT 2, it is having a vocabulary size of around 50,000 tokens. Okay, you can see here all those tokens are present. So here now, this is a single row vector, single column vector having 50,000 tokens. Okay, this is having 50,000 tokens, and for all these tokens, the probabilities are found. Okay, the probabilities, how these probabilities are found, this is a final value. If I want to show you very simply, you can see here the final output is there now, which is the summation of different dot products. Okay, which is the summation of different dot products multiplied by weights. Okay, so this is a final scalar value, right? So these logits are those probabilities, the scalar value. Okay, these are scalar value, and these logits are scaled again. Okay, this is very important and very interesting topic, and I really like this feature. How these scalings are done, you can see here there is a probability value that is minus 35, and this is divided by temperature. Okay, and what is the temperature here is 0.8. So now if I set the temperature to 0, or it can't be 0, obviously it can't be 0. If I set the temperature to 1, the minimum value is 1. Okay, sorry, 0.1. If I set the temperature to 0.1, I will get the most definitive sentence, okay, or most definitive prediction. So what do you meaning of most definitive? Definitive means, let's say I am Dr. Kanaka, I am working as scientist in IAB. Okay, so here let's say this is a sentence, and if my input to the model is Kanaka working as a scientist at IAB, okay, it will predict the next word. Okay, IAB means what? IAB is present in the Ranchi. It will predict Ranchi. But if I increase the temperature to 1, 3, okay, temperature can range up to 10. Okay, if they increase the temperature to 10, it will predict very random words. Means the model will become very creative. Okay,